Hi everyone, we are so excited to have Vikram over here. He grew up in Mumbai and then he studied computer science at the University of Delaware. He founded Social Work, a TechCrunch 50 startup, which was early in the enterprise collaboration space, and that led him to the LinkedIn early in 2010, where he worked on the various things from the API platform and ad serving to moving LinkedIn.com to a SPA architecture. He now is based in Canada and is building an open source GraphQL to SQL compiler platform called the SuperGraph. And that's what we are going to learn in this entire talk. Super excited to have him over here. Thanks a lot for joining in for the session. Over to you, Vikram.
Hi. Well, thanks for having me. Um, I'm going to just start off talking a little bit about my background, I guess, and why I kind of like Go and choose Go. I think it's kind of important. Um, I've worked on several platforms, like languages of different type over my career. Starting with even PHP to a lot of Java, and I've always had this issue where there's a lot of baggage that comes with the language. Never having a good enough standard library, or just headaches around how to write tests. You have to find 15 different ways to kind of approach it, and nothing standardized. It's not built in. Or even just like setting it up, different versions of the language sometimes need some complex environment set up, or it's just all of this stuff that you have to deal with, or the language itself, right? Languages, many of these languages are so complex, people don't want, like Scala, for example. I've noticed that there are people just using a subset of the language, and that's something that needs to be decided with the team beforehand. So it's and then finally also deploying the application. Like deploying its Python application, for example, is not the easiest. You have to set up the whole environment inside Docker, and I've always struggled with it. Compared to all of that, I found Go had this C-like simplicity. So it was really simple. You could just easily get into it. You just a single Go compiler works really fast. The standard yes, I obviously work beyond the standard library and use other people's packages, but the standard library for the most part works really, really well. I mean, I can almost get 80% through most applications, maybe even 90 with just the standard library. Coming with all of this background, I was always motivated to write less code. So because more code equals more code you have to maintain. This is just stuff I've learned over my career, right? Like most people want to output as much code as possible, and sometimes that makes sense, but for the most cases, I've found that just thinking through a problem is much better than kind of like jumping into code something, and the result is less code. And or you delete a significant portion of like an existing code base and replace it with something smaller and better. So kind of going with this whole philosophy of less. I've noticed another common pattern in my career, especially with web development. And if you're writing any kind of applications for the population out there on the internet, you're always going to have to you're kind of building this front end application, then you're building this back end API application, and that's kind of like a common pattern. And yes, the front end world is still very, very very library heavy and not as simple as Go. But even writing the backend in Go, it turns out is not exactly that simple either, because you have to figure out the right path through REST, right? Like what are the URLs that you're using? How will those be structured? What will you name each one of these things? Are you going to really build compile controllers and models, or are you just going to jump into writing REST handlers directly? So there are all these decisions to be made, and then most of, like, if you try to write a API service from scratch, then there's so much you're missing out, right? I mean, you need rate limiting, you need some kind of like cache management. There's so many little things. If your application is not an SPA, then you probably by SPA I mean single page application, like a React app. Then you probably need CSRF kind of management. There are just many pieces. And finally, 90% of the applications we write for web stuff are basically like things that talk to databases. We And also a large number of us don't use databases as effectively as we could, right? Because writing SQL is a massive context switch. You're working in this language, Go, whatever, and you're working with structs and everything, and then suddenly if you have to write this kind of complex piece of SQL, which it feels like another world, right? SQL does not follow any of the structures that a language we're used to do. So so kind of making all of, like, bringing all these things together. I began thinking about like, how can I make backend programming easier? Like, how can, in this day and age, we not have to go and again decide and build all these REST endpoints, build all these structs, so one struct to write into the database, one to generate the JSON to send back to the user, maybe another struct for the request that comes in, and then obviously work with some kind of an ORM. Most of the ORMs in Go are I mean, they're okay, but they're not as mature as some of the ORM packages that come through. And by ORM, I mean object relationship mapping libraries. The famous one in Rails is Active Record. There are a couple big ones in Java. I forget. I think Hibernate is probably one. And Go has a few, but I've struggled with them, honestly. I don't, and I prefer to write direct SQL than kind of using most of these. And obviously the ORMs are quite limited. They don't allow you to use all the capabilities of a database like Postgres. They're quite generic, so even a simple join sometimes is quite complex. This ends up with a lot of code for something relatively dumb, right? I mean, you're reading some users from a database. Maybe you're getting getting all the products they bought from another table, and at the end of the day, even after you build this, it's the front end application is moving at a different speed. It's moving faster sometimes, and or maybe slower. And anyway, so long story short, the front end team is disconnected, and they always require changes, right? So it's usually the front end team coming back to you and asking you for another like property or another value, saying, hey, thanks for giving us the user and all his products, but we also need say we need all the votes on the product, or we need all the comments that this user has made on these products, as well as the comments that all his friends have made, or there's all these requirements that keep the API changing, and this requires you to go back, change your structs, write more SQL code, or struggle with the ORM again. And this, honestly, at the end of the day, this is, I don't feel this is why I got into computers, to build more REST APIs per se. It's sometimes, yes, this is like the bridge to get into more exciting, the more meaty parts of your application. But in terms of day to day, this is a huge part of a lot of web development work, backend work, and it's kind of boring, And the term we all use for this kind of work is building CRUD APIs, right? Create, whatever, update, delete APIs. And usually you have to do this. There's really no way around this. But what if there was a way we could automatically generate these APIs, at the same time have them be really flexible, so that the front end team can get the data that they need without really interfacing with me, and hopefully have all these other things that you need out of web API services, like REST and like rate limiting and all of these little pieces that you need, authentication, have all of that. Tracing is another big one. All of these kind of baked in. I started kind of looking around for solutions, and when I saw GraphQL, I thought I stumbled onto something really cool. I think GraphQL is a nice way to represent the data we need. Often the data we need is in JSON, right? I mean, we're kind of living in this JSON world, and GraphQL is close enough to JSON to kind of make it very familiar to front-end developers who spend a lot of time working with JSON. Like if instead of JSON, if I gave them some kind of complex DSL with functions, it's not as natural, right? I mean, because essentially GraphQL could have just been JSON. It's not. It's its own kind of structure, but it could have been. But the problem with GraphQL that I saw early on was it still required me to do a lot of the same stuff. GraphQL it's not magic. It's just like a way to it's just a structure. It's like a protocol of some sort. That's not even heavily standardized or anything. It's just kind of a way to communicate. But the backend database code you still had to write. I mean, if you had a REST application and you wanted to introduce GraphQL to it, you still have to go in there and write all that GraphQL database, that code, the GraphQL parser stuff, or maybe use a library there. But then take the data the request that it gives you, and then write out all the database requests for it. So it's still the same-ish kind of work, except now it's a little more complicated because GraphQL has way more complexity than a REST endpoint, essentially. And then there's this problem with n+1 queries that many times people deal with. If for example you're fetching a user and then his products, do you like fetch all the users first, then kind of hold them in memory, and then iterate through them and go and fetch the products for each one of them, and then kind of join the two together? So, it's not the most efficient way to deal with databases. Databases are evolved over time to join, to be really good at joining stuff, especially Postgres. And essentially, when you make those multiple calls, you are putting additional burden on the databases, all these new connections and all the latency involved with, even on your application, right? Because you're making you're opening all these new coroutines, and each one is waiting for data to come back. So your request is essentially slowed down. It's not as fast as it could be. So I started to look into this as a compiler problem. Like, the problem is, if GraphQL could just turn into SQL, then problem solved. That gets us 80% of the way there, and that's clearly possible. I mean, we turn one language into another all day long, right? I mean, that's what every compiler out there does. So this cannot be any harder. And additionally, what kind of I started looking into Go itself, the language compiler, which is so easy to understand, the parser, the lexer, Go AST. It's just so readable. And that kind of motivated me to kind of explore this problem further. And I initially started off with saying, hey, let's just write a lexer parser. Let's get like an AST, just the basic stuff that nothing unique to what I was doing, but to Supergraph. But a lot of GraphQL engines do that. But I wanted to do it really efficiently and make it so that this compiler could be actually in real time work as a hot path for requests coming in. So after I reached that step where I actually had an AST. An AST is basically an in-memory representation of a language. Every compiler out there does it. The Go compiler does it. C does it. I mean, if most of you, if you've done if you've taken a basic compiler class, an AST is a pretty common thing. It's just a data structure to represent the data before it gets converted. It's a tree. So once I was at that step, and all of this is really easy to represent in Go. It's not. I did not need any special libraries or any of the stuff. It was just dealing with the bytes. So you just kind of have a pointer. You walk through the bytes. You do this step called tokenization, where you emit these little structs saying, okay, I just came across a word, I came across a curly, I came across a space, and this step is called the lexer, where you generate all these tokens, and then you have the second step called a parser that reads all these tokens, saying, hey, I have a word which is a name. I know my language has a name, and then after that, I need a curly. If I don't have a curly token, then I throw an error. So that's kind of how how a parser, lexer parser works. So so yeah, once I had the AST, I needed information from the database on tables, columns, and that kind of stuff. So at that point, I that in Postgres, that's really easy because Postgres gives you that as a query. You can actually query the database, and you can say, hey, can you tell me about the schema of this? Can you tell me about the whole schema? Can you tell me what tables are there? What each table contains? Like in terms of like columns, what are the type of columns? You can ask it all this information using SQL. So I then queried Postgres, and once I had all of this information, I built a kind of a graph with that too. So now I have the original parsed data, that's a tree, and all the whole relationship graph of the database that says this table is related to this table, and this table is related to that one. And essentially, this piece was the most complex. Actually, obviously building all this graph and then kind of putting the two together, and writing out the SQL. So at this point, I knew the tree, saying, I knew that there would be like a user, and then that had a nested object in it, which was like the products. And another thing I wanted to do here was generate really efficient SQL. I did not want this to generate 50 queries out into the database. So one of the goal was of the project was, no matter how complex the GraphQL be, we can only generate one SQL query. That's it. So the query could be relatively big, but that's not a problem. Yeah, the size of the query does not affect the time as much. I mean, the size of the SQL query does not affect the response time as much. So yeah, so in the end, that's basically what Supergraph became. And it's I managed to achieve that, and it's quite a big project now. Relatively for me, in terms of open source projects that I have built before. It's got 1,000+ stars on GitHub. It's got several production deployments. There are companies and startups that are now using it. And the magic of Supergraph is that you can just bring up this Go service called Supergraph, point it at your database, and start writing GraphQL queries against it. It even has a nice web UI where you can, it gives you autocomplete capabilities. In GraphQL, that's called introspection. But essentially, you could say query, users would like tell you what the options under you are, users, and whatever updates. And then you could go at curly nested, and then would say, oh, the user has these other related things, products, blah, blah, blah. Which one do you want, kind of thing. So it's really easy to craft your query. And when you finally hit, send, the compiler works with its magic, and you get JSON data back. So and you get it exactly in the shape you need it to be. So the how you've defined the GraphQL to be, and you're not writing any code here. You're not writing any SQL. There's nothing to maintain. As Supergraph and its knowledge of improves its own SQL capabilities, your APIs improve magically, because that's just how it is. And in production, if anyone's worried about the overhead of a compiler actually for every request or anything, that's not an issue either, because in production it actually caches the compiled queries using something called database prepared statements. And so essentially there's really no compiling happening. So yeah, I found this project, like Go, to be like a really amazing language to focus and build such a thing. There's a lot of tests that were required to get all this working right. And I could just write the code in one window, and I could have the test. You could write the test in the other window, and the Go compiler is so fast that it would actually run the tests as I was literally writing some of the code. So having worked in Java and on large code bases, I found this to be, almost magical. The performance of the compiler really, like I'm talking about the Go compiler, it just was like, it works like magic to help me be more productive, right? I mean, I've waited for code to compile for hours. So, I don't like that. You have to write a lot of code and then later figure out what was wrong with it. So I work much better when I'm just writing little code and in real time, something, the computer is working for me to tell me, how well it's working. Is it working? Is it broken? I go much faster that way. So anyway, so going on about Go and why it's so great. But believe me, if some of you are just kind of beginners into Go, it's definitely the language that for all these reasons, a lot of the world is now adopting. I see Go everywhere, like Apple, Google, obviously, but like every one of these big companies are themselves has Go, and every startup out there is also picking up Go. It does not mean any other language is, not like Rails is still very, very, big, or Java for that matter. But Go is definitely like, I'd say the startups that really know their stuff are picking up Go. So that's kind of like a small signal into the, the quality of maybe the code and the technical know-how of the team. If you, kind of hear about Go being used in there. So yeah, so Supergraph today is, I think I've achieved a lot of what I wanted to. And once the basic compiler became really good, I added on a lot of really cool features that I wanted to work on. For example, mutations, where you can then have inserts and updates, but again, in a GraphQL way, where you could have them nested. So you could have a user created and then his product object updated, and all of these kind of like, multi-table updates happening through a single query. And this is because Postgres allows you to do that. There is, this, I went deeper into SQL and there was stuff I had never heard of before that I discovered, which is really cool. Full text search. This is another thing that Postgres gives you, and Supergraph just kind of exposes it. Infinite scroll, to kind of implement that in a way that scroll, so that it's really efficient, is hard. You have to build something called a cursor, and it supports that now. And one of my favorite features is subscriptions, where and this really takes to build it. I used a lot of the sync package that comes with Go. This is, when they always talk about how great Go is at concurrency. Most of us don't notice that, because if you're working in like the web front end world, your each handler is a Go routine, but you're not really doing any concurrent stuff beyond that, really. But in this, I really had to handle real-time updates and communication across different WebSockets. So there was a fair bit of the sync package that I ended up using, and I loved it. I mean, it's way better than jumping to mutex locking everything. In my case, I ended up using something called the sync.map, because essentially when multiple threads or Go routines are trying to update a Go map, that you cannot allow that to happen, right? Without guarding the map with some kind of a locking mechanism, because the Go maps are not thread safe. You cannot have that updating happening. Half an update will happen here, it'll switch to another thread, and that thread will try to do something. It'll just mess up your whole thing. It'll crash. And similarly, there was another package called sync.do that a function, sync.do, that I thought was really great, because that allowed me to do an operation just once. So if there's something that needs to be done, and that needs to be done just once, for example, like compiling a query in production, then and if 1,000 requests come in and that query is not yet compiled, then all those requests need to wait, and sync.do will handle that. It will make all of them wait. It will do that one task that needs to be done, and then allow the requests to go through and use them. So the first request would activate that, and the rest, 9,999 requests would have to wait, right? So having this kind of like capability out of the box. Channels, using so when you have many WebSockets kind of connecting in, and you need to send real-time updates out through all of them, you're going to have to leverage something called channels. And then in this case, I had a channel per WebSocket, so I had access, and I had to build like a map with all the channels on one side and the IDs, and then when an update came in, I find the right channel and send the update up that channel. So that stuff like that is not available in any language. I mean, I would be handling some kind of weird. I'd have to build all this myself, some kind of weird, messaging system within an app, or use a non-standard library. But this is like core part of the. I love that. And I'm excited to like explore the sync package more. You don't always get a chance to make full use of it, and when you do, it's pretty cool. So yeah, I've spoken for quite a while. Do people have questions? So I am trying to see if I see comments or questions anywhere. Sorry, I'm just see you. Sorry, I'm trying to find the link to. There, sorry. I found the YouTube. I assume that if there are any questions, they would be here. What else can I, yeah, so at this point, I am looking for more people to contribute to the project. It's well documented. As and the code is clean. I've tried to separate it into packages. I found when you're working on like a big complex code base like this, it's best not to get too ambitious about the structure of the project early on. It's best to just start coding. It's okay if everything's in one package. It's even okay if everything's in one file. Go. It doesn't really matter. I found like it to be much simpler to just keep coding, have all your functions in the same package, and it saves you so much effort having to context switch between files and like look for the right file. And then when you feel something's you're like some piece of thing you're working on, say there's code to render all the columns, and you realize there's just a whole series of functions that are related to that, and it's so easy to just kind of copy those out, put them in another file. You're still in the same package, but now there's less code in that same file. Also, another thing I would advise people to do is write smaller functions. Write more functions, but smaller. It's not. You don't really have to write a test for every function. I mean, I don't see that as being practical at all. It's yes, for more complex. I end up writing more top level unit tests where I'm testing like the compiler in different ways, or there's certain complex pieces of the compiler, then I will make sure that's extracted into a function, and I will write a test for that. But if I have 1,000 functions that kind of uses, I'm not going to sit and write 1,000 tests for each of that. There's no way the project would move if that's what I was trying to do. But like integration and top level tests really helped me a lot more. So I kind of go with that. Yes, write tests. They are much better than going and trying to like deal with. If you're kind of building a new feature, it's best to just write the test that will satisfy that feature, and then keep writing the code and have the test run in the background, as opposed to trying to go into a web UI and recreate the state and then click go every context switch into a browser. Having a test going just keeps you in context. And and it's you don't break your chain of thought. Um, Let me see what other advice I can give people. There are a lot of gotchas in Go that you have to be careful about. For example, if you're using the range loop over an array of say of objects of structs, and then the value that comes back from the iterator, that is not a value you want to pass around because that changes itself. It's kind of like a copying in, I'm not going to get technical, but don't use that value if you're trying to like pass a pointer around somewhere. Use a direct index if you want to do that, like array I. um, there are simple things like that that can the compiler does not catch. There are if you are writing multi-threaded kind of concurrent code, there are there's a race detector which is really good. You could I forget the exact command line. It's test dash race, I think, which can actually point out things that might be going wrong. Be like you're using a map um, to be concurrently accessed by many threads. That's clearly a big no-no. For example, it might probably will catch that. Um, Let me see what else. Yes, I would say stick to the standard package as much as you can, but it's not, it'll just make your life simpler. Standard package itself is getting so much better, and there's a lot of lot many eyeballs on that code base. Um, I found most external packages to be pretty solid, but if the external package is not that big, I'd say, or if it's just a file or two and someone's built something interesting, I'd say it's sometimes better to just like copy it into your own code base as using the library, because it's uh, sometimes these really small packages are not maintained at the rate you need it to be. Um, and you're not dealing with it as an external dependency. Obviously make sure the license is compatible, or if you're required to like copy the license into your own project, do that, whatever that be. But you don't have to like import it as a it's better just to have the code that you can edit really quickly. um, Let me see. Use the context. Use the context package. That's really nice. Like in Supergraph, authenticate. Like when a request comes in, it's either authenticated or not. So there are two roles: a user or non. And a user role means there is a user ID available. And the way that works is and how I use the context package to propagate that ID through all the functions, because I never know where that's needed. And adding a new member ID, user ID, sorry, everywhere across my thing, it's ugly, and it's not a required value, right? It's most functions should work either with that or the lack of it. So context is a great way to pass that around. The context package is really good for another thing, which is the with cancel, where you could basically, if you're doing a lot of I/O, I mean, most people are talking to a database, making remote calls, whatever. You want with cancel, so you want a timeout, because when you're writing these high performance, high scale services, it's usually the tail latency that gets you. It's usually like this, like if you plot the latency on a graph, then it's the tail. It's usually the few requests that take the most time for some reason will then hold up everything. So or slow down everything. So if you put a hard cutoff with a timeout and pass that context around, saying, okay, 5 milliseconds, I don't care, then what ends up happening is that becomes like your ceiling for latencies, right? I mean, nothing goes over that. So that's really great. And then all you have to do is set that at the top level and make sure that context propagates everywhere. So so that, yeah, I always do that. Try it's a really great practice to have. You can also pass like data in the context package, which is another great thing. But don't extensively overuse the context package. Don't don't try to send giant structs and stuff. Just use it for single values. It's not a data pipeline or something. Let me see what else are. Yeah, don't. Yes, this is another very big one, and I get asked this question a lot, especially by people contributing to Supergraph. To be like, hey, should I go with a pointer here, or should I just allow the system to copy? In Go, basically what happens is if you're passing a struct around, right? Say you're passing it as an argument to a function. Um, you can either pass it as a pointer where you'd be like user, then you'd be like and user, so it'll be like the pointer to user, or you would pass user itself where there would be a copy happening, right? And psychologically, a lot of us assume the pointer is faster, right? Uh, and they're like, oh, let me just use a pointer. It's faster. It's faster. Everywhere you end up using a pointer. It's also kind of neater. Sometimes you're, sending your response object now. If it's not a pointer, then everywhere in your error you have to, add it. You can't just do nil. Uh, so people tend to kind of use that a lot, but I would say don't, because that's not always true. I mean, does not mean a pointer is faster than a copy. This copy is not not some slow copying operation that's happening. I'm not going to say exactly what I don't know exactly how it's copying it, but it's using a really efficient processor, opcodes, or memory. Your memory device itself is having some kind of mechanism to do this. But long story short, it's super efficient. And if your struct is not big, and don't have big structs, just like I mentioned, have small functions, have small structs, and they mostly would fit in your cache line, so the copy would be even faster. And when I say cache line, I mean CPU caches. While if you have a pointer passed around, it's possible that pointer, I'm not saying, obviously this is more complex because Go does something called escape analysis, but there are cases where your pointer would escape. And that means it's now, Go puts it not close to the rest of the data, but it puts it somewhere far away on the heap. And in today's world, where the processors are not getting any faster, reducing calls to the heap, like jumping all over memory, is really a solid way to keep your application from not being slow. It is not cheap to jump randomly around memory, right? If you have an array and you have to walk down a list of like an array object, it's much faster than walking through a list of pointers like a tree, right? The array gets inlined into your CPU caches. It's called memory locality or cache locality, and then it's really fast, as opposed to you having random pointer locations across memory that you have to jump to, and the CPU needs to do a like context switch of some sort to actually get you there, and flush the caches, and kind of like change the whole world, which is very slow these days. I mean, in context of everything else. So yes, just don't prematurely optimize anything. Just go with copy. Unless you have a very large object, and that it's an object that's going to struct that's going to live for a long time, like you keeping it stored as a global or something, in which case, yeah, pointer may work. Yeah, so that's kind of like I'm kind of blending some of my learnings and understandings of Go with Supergraph, because essentially Supergraph is something I want it to be easy. I don't feel Supergraph is something that needs an hour of someone you're listening to an hour of someone talking about it to understand it. It's essentially there to like I use Supergraph now in all my applications. So I'm working on a couple ideas, and now having Supergraph as the backend for it is really great. It's like literally reduced the code I write by 90%. So now I focus on things like authentication or sending out special emails or those parts of the app, right? I mean, maybe some kind of like a really cool parser or AI thing. And I'm not dealing with this CRUD stuff anymore. I just, my application in React or whatever, the front end, issues GraphQL calls, and boom, I get the data back. So there's not a line of code there. If there is something really specialized and it cannot do it, then I can write an API for that. But for the most cases, leveraging the power of Postgres, I can do almost everything. I can have materialized views in Postgres. It works fine with Supergraph. That's when you have a query that's pre-computed and the data is just available to you. Or you can you can use triggers, and I love using some of all these capabilities that Postgres give you. It just makes everything more solid, and and less. I have to deal with less somehow. Always there's less code in the application level. If I sometimes just having a trigger is much better than having some kind of event parsing, message bus architecture that kind of like does the same thing, but then they have to have a message flowing through the whole system, and different services listening to it and then making the same update that a simple trigger on a table does. So keep things simple is really important. So yeah, that's all I have today. Yeah, if you guys have questions, I think we can go with those. I'm not super familiar. I can wondering what the questions would be. Okay. Cool. So I will leave this to